As always, let's start with a short review of what we did yesterday. First, so if we're going to simplify, if something is in simplest form, they don't have parentheses. So first, 2 times 2 is 4, x times x squared is x to the third. Outer, 2x times 3 is 6x. Inner, negative 4 times 2x squared is a negative 8x squared. And last, negative 4 times 3 is a negative 12. This is not in standard form, so I'm going to rewrite it with descending exponents. So I'm going to rearrange the x squared and the x term, making sure that I don't forget what sign goes with which. The 6x was positive, the negative 8x squared transferred here, so it's minus 8x squared. The second example was from a very long time ago, scientific notation. Well, not that long ago, a couple months. Remember with scientific notation, it looks similar to two binomials being multiplied together, but instead of a sum and a difference, these are multiplication. So you would not do first, outer, inner, last. You have to, since this is all multiplication, remember this is where we rewrite using the associative and the commutative properties, putting the numbers together and the base tens together. So 2 times 6 is 12 times 10 squared times 10 to the third is 10 to the fifth. Now this is where many of you stopped, but remember we need to put it into scientific notation, and it is not because of this right here. Remember, this has to be between 1 and 10, so we have to change it. So one way that we thought about this is if we are putting this in standard form, we'd have to go 5 this way, but we have to really come back and go 1 further. So 1.2 times 10 to the 6th. And the other way we talked about it is if you had moved the decimal one place smaller, we had to make the exponent 1 bigger. So I'm hoping by the time you've watched this, you've already had a chance to use the exploring shortcuts when multiplying binomials. That exploring worksheet, so the 2 special cases, that will really help you see the pattern and understand the pattern. So I'm hoping this is just a review for you. So there are 2 different types of special cases. For both types, you could just do the first, outer, inner, last, or the FOIL method and get the correct answer. The reason this is so important to understand the shortcuts is for the next part of the unit, factoring. So one more time, what hopefully you found out is when you are multiplying the product of a sum and a difference. In other words, the 2 first terms are the same, and the 2 second terms are the same, but one is an addition and one is a subtraction. If that's the case, it's like a type 1. And I hope what you found out is when you do the first, outer, inner, last, the outer and the inner cancel each other out. So you're left with the square of the first minus the square of the last terms. So first, outer, inner, last. The middle terms always cancel out for this type of problem. And again, what makes it this type of problem is that the first terms of the binomials are the same, the last terms are the same, but one is addition and one is subtraction. So our answer would be x squared minus 49. So what I'm hoping is that you've noticed that to get your final answer from factored to expanded, you square the first term and subtract from it the square of the last term. The square of the last term. So to practice, I'm going to check to make sure that it fits. So my first terms are the same, my last terms are the same. One is addition and one is subtraction. So I'm going to square the first term. 3y squared is 9y to the fourth. I'm going to square my last term, so 4x squared, and it is going to be subtraction. And again, the reason this works is because every single time the inner and the outer turn out to be opposites, so they cancel out. Alright, so the second type is squaring binomials. It's when the first and last term are the same, like in type 1, but now both are either addition or subtraction, not one of each. So I have my two terms in the binomial, a and b, and a and b. They're the same, but now they're both addition, or they're both subtraction. And what I'm hoping you discovered when you were doing your exploring is that when you do the first and the last like normal, so a squared and the b squared, so the first and the last, but the outer and the inner turn out to be exactly the same. A times b for your outer is ab, and your inner is also ab. So you take their product and you just double them because it turns out to be exactly the same. So a squared plus, I find the product of the first and the last, ab, oops, and I have to double it. So plus b squared. So I square the first, I multiply the two terms and double it, so a times b and doubling it, and then the opposite of b, or negative b times negative b, is a positive b squared. And this is negative because this would have been a negative ab plus a negative ab. So we multiply and then multiply that by 2 to get our term in the middle. Again, you don't have to use the shortcut to get this answer, but I know what's coming up in the next part of this unit, and it sure is going to save you a lot of work if you recognize this. So the shortcut is square the first term add or subtract, depending on what kind of problem it is, subtract double the product of the first and last. So that's the first thing, the add or subtract, the double, so multiply the first and last together and then times 2, and then add the square of the last. Alright, so let's practice that. The first thing it says is to square the first term. I always, before I do this, check to make sure that it fits this type. Are the first terms the same? Yes. Are the last terms the same? Yes. Are both either addition or subtraction? Yes. So it fits. So I'm going to square that first term. 3y squared is 9y to the fourth. And then I'm going to, and actually I think I will write it out this way first. 3y squared squared. And then I'm going to subtract, because it's subtraction in the problem, 2 times the first term times the second term, and then I'm going to square, I'm going to add to that the square of the last term. So once I simplify, 3y squared squared is 9y to the fourth. 2 times 3 times 2 is 12. Y squared times, y squared times x, remember alphabetical first, is x y squared, and then I'm going to square the last, which is 4x squared. Alright, two more quick examples. I'm not telling you what type they are. We've got to figure that out. So I'm going to look here. Does it fit any of the special cases? Well, I have a 2x and a 3 and a 2x and a 3. So this is definitely because both of the first terms are the same and both of the last terms are the same. Now I just have to decide if it's type 1 or type 2. Well, with type 1, one has to be addition and one has to be subtraction. And both of these are subtraction. So this is squaring a binomial. So we're taking this and we're just squaring it. So it has two factors of the same thing. So that shortcut is you square the first, so that gives me 4x squared. You multiply the first and the last, so 3 times 2x is 6x times 2 is 12x, and it's subtraction here, so it's going to be subtraction here. And then you square the last. Negative 3 squared is a positive 9. So really, that last term is just the last, negative 3 times negative 3. The first term is that, so 2x times 2x. And again, where we came up with that middle term is when we do the outer and the inner, they turn out to be the exact same thing, so we just double it. So let's do this last example. See if it's one of the special cases, so we can use that shortcut. 2x and 2x, 3 and negative 3. So the first terms are the same, the last terms are the same, but one is addition and one is subtraction. So I'm going to square the first term, so this is the easiest. It fits that type 1, so I'm going to square the first term. I know the outer and the inner are going to disappear, so then I just have to subtract from this the square of the last term. And then that's it. So I suggest, even though you can do first, outer, inner, last, the FOIL method to simplify, I suggest you really pay attention to when you can use this shortcut for when we get into the next part of this unit.